Mathematics is one of the most hated subjects that is studied at school. From the long formulas that need to be memorized, to the dumbass teachers that don't want to be there, it's an absolute nightmare to learn. Despite this, maths related content has some of the most viewed and replayed videos on the internet. And in this video, I aim to see why that is, as well as see if these videos are actually helpful, or is it just more bogus that's being fed to the NPC audience? So sit back, relax and enjoy watching a civil engineering graduate trying YouTube maths tricks. Okay, before I give you my opinion on this trick, I want to rate all of these tricks on two categories. Number one, does it work? Number two, if it does work, would I teach that method over what I would personally use instead? So, does this trick work? Well, yes, this is an alternative method that you can use for the standard algorithm. As you can see with this extra example that I'm doing on my Paint document, you can see that the trick is very easy to learn and that I was able to do it with relative ease. Hell, this guy thought that the trick didn't work and I got to prove him wrong live in this video. Thanks for the content. Would I teach it instead of the standard algorithm? It depends. You see, what do you notice about all the examples that I've used? Exactly, they're both double-digit numbers. When you approach triple digits, that's where the standard algorithm really shines, because then there's no limit as to what you can multiply. Because when we're doing the standard algorithm, we're just using single numbers multiplying by single numbers, and then we carry on the 10 onto the next number. So the maths itself is not too difficult, it's just a little tedious. And if a student is able to master the standard algorithm, then I don't see any reason why not to teach them a little shortcut to do a 2-digit number times a 2-digit number.
In order to solve this equation, do not expand the binomials or take square root of both sides. Instead, first move x plus 6 squared to the left and apply the difference of two squares formula.
Does this trick work? Why, yes it does. The way the difference of two squares formula works is that we take two brackets, each containing the square root of the two terms, and then we alternate the sign of the negative term. In this example, however, there are two square brackets rather than two terms. That's fine, as the method works all the same. All it means is that we collect the like terms as shown in the working. From here, we set the roots to be equal to 0, and then we solve to find the two values for x. Would I teach this over what I would have done? Well, to answer that, we really need to look at the other methods. Firstly is rooting both sides to remove the squared bracket. This won't work, as you would only have one solution as opposed to two, which is very important as this is a quadratic equation, so there has to be two solutions, meaning the other method would involve expanding the brackets. This is long. What we would need to do is use the Pascal's triangle method to expand a squared bracket. We then put one side on the other side to set the whole equation equal to 0, and then collect the like terms. Only then would this enable us to try and factorize this equation, which in of itself is a multiple step process. I think you know where I'm getting at with this. Of course I would teach this method over the alternatives. The difference of two squares is a great tool when doing maths that can determine the difference between an A and an A star. In fact, I have seen questions at job interviews, university entrance exams, and even in maths tests like the Senior Maths Challenge, questions that require the student to realise that we have to use difference of two squares. In my opinion, it's a very undertaught skill which can make a mountain of difference to get the desired results. Before we continue guys, just a quick shout out to my Discord server down below. I've been talking to my community a lot and they have been asking me big man questions, which I give answers to all the time. So if you don't want to fail your exams, join my Discord server and subscribe to my maths channel, as I also have a channel where I teach you lot how to do basic ass arithmetics so that you don't struggle in your exam. Okay, back to the video.
Cube root of 343? Oh, that's so easy. 3 plus 4 plus 3 equals 10. Minus 3 equals 7.
Does this trick work? No, it doesn't. Does this trick work? Only if it's a Pythagorean triple. Let me explain. What we need is that the two numbers in front of sine and cos would be the smaller length of a triangle, and then the right hand side, so in this case 17, would make up the bigger length of this triangle. You can double check this by doing a squared plus b squared is equal to c squared. Now, the left hand side is usually written with a singular trigonometric function with the angle alpha being subtracted in the function. This is because this equation is so much easier to graph than how we left it at the start. To work out what angle alpha is, we need to use the double angle formula for cos A minus B. And then we compare the like terms, which give us cos alpha as 15 over 17. Now what we can do is rewrite our original question, but we change the left hand side to our cos theta plus alpha method that we just described. And it's still equal to 17. Because it's equal to 17, the 17s will cancel out and the cos will just equal 1. And if cos is equal to 1, the angle in the bracket is equal to 0. Therefore, theta is equal to alpha and the trick works. However, what if the equation equals 16? Well, we would still need to do Pythagoras' theorem so that we can find out what the largest length is. As you can see, just because I used the same numbers, it's 17, but it's different to 16, meaning that we can't use the trick shown in the video. We can still turn it into one trig function, this is just the way that I would do it, and then we can do a similar trick for sine, cos, and tan alpha. Then we can plug in alpha again into the equation to solve for theta, but this time, cos won't be equal to 1. It'll be equal to 16 over 17, meaning that theta plus alpha is equal to 19.71. Therefore, when we solve the equation for theta, it's different to what it is for alpha. And by the way, this is all under the assumption that both theta and alpha are between 0 and 90 degrees. This equation could have infinite solutions. Would I teach this method over what I already do? No. If it's a Pythagorean triple, no, I wouldn't. What I would do instead is I would ask you to put it in the cos theta plus alpha way. And then from there, you can do the trick shown on the screen. I just think that if you teach a student a trick right off the bat, especially one that's inexperienced, chances are they will use it as a cheese strat and they won't understand the context behind it.
Here's how you could approximate the square root of a number. First, take the biggest number that you could take the square root of, less than 102. In this case, it'll be 100. Square root of 100 is 10. Then, what you want to do is 10 plus the number that's left over from 102, meaning if we take away 100 from 102, we get 2. So we put the 2 on the top. Then, on the bottom, it's always going to be 2 times the number that we came up with, which is 10. And that's 10 plus 2 over 20, or 10 plus 1 over 10, or 10.1. If you actually take the square root of 102, put it in the calculator, you get 10.0995, which is pretty darn close.
Does this trick work? Well, to answer that question, I created a spreadsheet. In this spreadsheet, I found what the nearest square was by finding the actual root, and it's just the integer value of what this actual root is. I then applied the formula shown in the video, and then I worked out the percentage difference. From my findings, here's what I found. Smaller numbers have a much larger percentage uncertainty between the actual root and the approximate root using this method. However, bigger numbers end up having a much smaller difference. As you can see, the only difference between these two numbers is this 0.6 at the end. But again, if we go to smaller numbers, and even like single digit numbers, the percentage uncertainty is massive. But again, if we go to big numbers, then the method works like a charm and it's almost no difference. So yes, this trick does work. Would I teach this method over what I currently use? Not in a million years. Here's the thing, guys. As awesome as these tricks are, especially with the square roots, think about when you'll need square roots in your day-to-day life. You'll either need it when you're collecting data from an experiment, or you'll need it in a non-calculator exam. In a non-calculator exam, it is always best to just leave the surd in surd form. You don't even need to round it. And in the real world, we don't need surds whatsoever. We have spreadsheets and calculators, and we need them in decimal so that we can graph the information. Approximate values just don't make any sense. Now, there are times where you are going to have to approximate the value and give an estimate, but all I'm saying is in the context that is shown in the video, I wouldn't personally do it like that. If I were to do it like that, then I would use one of the other methods, like the spider method or the spiral method, or the Newton-Raphson method. I wouldn't just have a known value for a surd and then approximate it. It just doesn't work like that. So as cool as this trick is, and it does work, I personally wouldn't teach it. Sorry. And that's it. Those are 5 maths tricks that I have proven, disproven, or given context to for you guys. Now you can go into your exam and use them knowing the risks, because you've watched this video. If you don't want to fail your exams, subscribe to my maths channel in the description and join my Discord server so that you can ask me anything you want. Please like, favorite, share, subscribe, and of course, keep on learning, as you have no idea what you're capable of doing. Mathematics! Mathematics! Mathematics!